So we're going to start off the year with a little pre-algebra review, just to make sure everybody's on the same page. And if you find that you're not, make sure you get in to get some help early, and we'll get you caught up. So here we go. Real numbers, fractions, percentages, all the basics you've seen before. We just, once again, want to be speaking in the same language. So when we talk about a number system, we talk about our natural numbers, which are counting numbers, 1, 2, 3, 4. And those all have to be greater than 0. When we talk about whole numbers, we talk about the counting numbers starting with 0 and up. Integers are both positive and negative counting numbers. When we talk about rational numbers, we're actually talking about any number that can be represented by a fraction. So any terminating decimal like 0.28, any normal looking fraction like 6/7, and then any kind of repeating decimal will also be able to be represented by a fraction. Now when we talk about irrational numbers, we're talking about most square roots. If we have something like a perfect square, for instance like the square root of 9, we know that's just the number 3. So the square root of 9 would not necessarily be an irrational number. And then pi is also an irrational number. And what we want to consider is whether that number is non-terminating and non-repeating decimal. And each of those two that I've given as an example here are non-terminating and non-repeating. Now all of these different types of numbers are grouped in the real number system. And below what I've given you is a chart that describes where all these fit within the bounds of their classifications. So if we go here and you're asked to classify what type of numbers these are, well, we know the overall classification for each of these are all real numbers. So I can say negative 15 is a real number. And I can also say that it could be written as a fraction, so it's rational. And it's also an integer since it's a negative counting number. If we go to 6.235, that's a terminating decimal, once again real. It can be written as a fraction, rational. It's not an integer because it's not a counting number, so that's it. Square root of 63, that's not a perfect square. If we were talking the square root of 64, which is 8, we could say that that's a counting number, but this isn't. So this is going to be a real number and an irrational number. And clearly this is represented as a fraction, so it's a real number. Oops. And a rational number. I'm going to arrange this from smallest to largest, so what we probably ought to do is get out a calculator. So in this case I have negative 1 7/8 and negative root 3, and I need to see which one is actually bigger. My guess is it's going to be negative root 3 in terms of a less negative number, but let's just plug in negative 7 divided by 8, hit enter, and that gives me a decimal equivalent, and then add negative 1 to that, and that's going to give me negative 1.875, I believe. Negative root 3, let's go back to the calculator, get a negative, and my root sign is right above the x squared, so I have to hit the second button, followed by the root, hit 3, enter, and that's negative 1.73. And then I've got 4.53 as given. Then I have to find out what the square root of 20 is, so once again use my root button, square root 20, hit enter, and we get 4.47. So now I've got enough information to arrange this smallest to largest. The larger the negative number, the smaller it is. So this is my smallest. Moving up, negative 1.73. And then 4.47 is smaller than 4.53. And 4.53 is last. So rewriting these, that's negative 1 7/8 is my first guy. Negative root 3, my second. Root 20, my third. And 4.53 is my largest. Now we're going to use our calculator to represent 0.36 as a fraction. So let's go back to our calculator. I'm just going to clear the screen by hitting the clear button. And what I'm going to do is I'm going to type in 0.3636, and I'm going to actually just repeat this quite a bit. And let's just do a couple more for kicks. So that signifies I'm repeating quite a bit. Now there's a function on this calculator that allows you to convert any decimal to a fraction. And if it actually doesn't convert to a fraction, if it's actually irrational, or if it's actually a fraction that has a denominator greater than 999, then it won't make it a fraction. So 999 is your greatest denominator that you're going to have. So if I hit the math button, and then if you look right up here on number 1, it says frac. So I can either hit the number 1 or hit enter. I'll hit the number 1. You'll notice that here's 0.36 repeating, and it says convert that to a fraction. So if I hit enter, then the fraction that makes is 4/11. So we write in 4/11. Okay, now in the next case, I have 1.28 repeating. So if I go 1.2 and then type 8 a whole bunch of times, calculator is a little slow, so just be patient. And then once I have that, I want to convert it. So once again, I'll go second. Sorry, I won't go second. I'll go math. Get rid of the second. That's not what I wanted. Just go math, frac, and then ask it to convert it, and it gives me 58/45. Now you'll notice I have an improper fraction here. I would much rather prefer this than 1 13/45. Okay, so let's just leave everything in improper fraction form for the year. Also, not a big fan of decimals. I'm a big fan of fractions, and we're going to write fractions whenever we can. All right, so let's talk adding and subtracting some positive, negative numbers, the general rules, and we should all know this, but this is just a refresher. When we take and see a subtraction, I just change everything to an addition by adding the opposite. I'll show you in the case that we have here. When you're adding terms with positives and negatives, if you have the same sign, add the numbers up and keep the sign. If you're adding different sign to numbers, then keep the sign of the larger number and subtract the small from the large, and you're done. So in this case, I have different signs. Going to keep the sign of the larger number, 20 is the larger number, and then I'm going to take and subtract the two. So that gets me a 12, and I have a negative. In this case, I have the same sign, so I'm going to keep that sign and then add the two numbers up and get 21. In this case, I have a subtraction, so I'm going to add the opposite of the number after it. So I've got 20 plus negative 30. Keep the sign of the bigger number, so 30 is a bigger number. Subtract the 2, I get 10, and I'm keeping that sign. Again, I have a subtraction here, and you'll notice that I'm going to add the opposite of negative 22, which is positive 22. I now have the same signs, so I keep that sign, which is a positive, add the two numbers, get 29. For multiplying and dividing, if you have the same sign, you get a positive solution. If you have a different sign, you get a negative solution. So here it's a different sign, so I get a negative solution, and I multiply the two together, and I get 24. Here I have the same sign, I get a positive solution, multiply the two together, I get 36. And the same works for division. Absolute value is the distance on the number line from 0. So how far is 23 from 0? 23. How far is negative 22.5 from 0? 22.5. And in this case, you want to treat the parentheses or the absolute value like a parentheses. So do what's in there first. You don't want to take the absolute value of each. So I take really 7, subtract 18 from it. So again, add the opposite. And we're going to take and subtract those two. So I get 11 of the negative type. And I say, how far is negative 11 from 0? That's 11. Moving forward, we're going to take and multiply fractions. So we remember that in multiplying fractions, you got a couple of options. One, you can just multiply the numerators. So I get 30 in this case. On top, on the bottom, I'd get 84. And then those actually reduce. 2 goes into both. So I have 15 here and 42 there. And I believe 3 goes into both of those. So I have a 5 here. And 3 goes into 42 14 times. And that's my solution. Now what I could also do is I could take and reduce anything on top of each other or across a multiplication sign. So in this case, 6 and the 12 both reduce, 1 and 2, and then I just multiply the numerator, multiply the denominator, and there we go. 5/14, 5/14. Either way you choose to do it is fine with me. I'd probably go with the way that makes less work in the end, but it's up to you. Now in this case, when we've got proper fractions, mixed numbers, however you want to call it, what I'm going to take and do is I'm going to convert those to improper fractions. So remember, 9 times 3 plus 2 gives me 29 over 9. 5 times 4 plus 1 is 21 over 5. I look and say, hey, 3 goes into both 21 and 9, goes into 9 3 times, goes into 21 7 times. That's all the reducing I can do. So then I'll just take and multiply 29 times 7, get 203. And then I have 15 on the bottom, and I'm done. Dividing fractions, remember we multiply by the reciprocal. So in this case we have 12/5 times 15 over 22. I have a number of reducing items I can do here. 5 goes into 5 once, goes into 15 3 times, 2 goes into 12 6 times, and 2 goes into 22 11 times. Multiply across, get 18 over 11, and you can leave it like that. Now in this case we have these mixed numbers again. I'm going to change them. So I have 23 over 4 divided by 8 over 3. Now I'm going to multiply by the reciprocal, so that's 23 over 4 multiplied by 3/8. Looks like I'm out of options as far as reducing goes, so just multiply it across. I get 69 over 32, and I'm done. Couple more. Adding and subtracting with common denominators. We remember we keep the denominator the same. Add the numerator. Any reducing that can be done, we go ahead and do. In this case, Common denominator, subtract the numerators. No reducing to be done, and we're out. When we have unlike denominators, what we're going to do is find the lowest common denominator, or the smallest number that both of these go into. I usually take the biggest one and start multiplying. 6 does not go into 9. So if I multiply 9 by 2 and get 18, 6 does go into 18. So I'll take 18 as my LCD. And what I like doing is writing down that new common denominator twice. I have to change the numerator. So in order to do that, I multiply by a form of 1. So to get 9 to 18, I multiply by 2 over 2, which is 1, so it won't change the value of that fraction. To get 16 to 18, I multiply by 3, so I must multiply the numerator by 3. In doing so, now I have to change the numerator of the new fractions. So I have 16 here, I have 15 here, and we get a total of 31 over 18. In this case, I can continue to multiply 7 a number of times until I get something that 5 goes into. Since these have nothing in common, nothing goes into 7 that will ever go into 5, I can just multiply those two numbers together. 35 is my LCD. Going to have to change my numerator, so once again, I need to multiply by 5 over 5 to this first fraction. I need to multiply by 7 over 7 to the second fraction. In doing so, I get 30 and 21. Subtract the 2, I get a total of 9 over 35, and no more reducing can be done, so I'm out. Change this to 19 over 4, 7 over 3. Nothing goes into 4 and 3 in common, so I'm going to take and multiply the two together to get a common denominator of 12. Once again, I'll need to change the numerators. To get from 4 to 12, I multiply by 3. So there's my form of 1. To get from 3 to 12, I multiply by 4. There's my form of 1. Multiplying the two together, 19 times 3 is 57. And 7 times 4 is 28. You're going to add those two up. That's 85 over 12. And I don't think there's anything in common in those two. Alright, so finally we talk about some basic percentage problems. There's really three types. 13% of 28 is what number? 73% of what number is, let's put a number in here, 18. Got to type that in. And 15 is what percent, of 123. So when doing this problem, let's go through and use this general approach. Percent over 100 is equal to is over of. That's just a quick way to remember it. So if I have 13%, there's my percent, 13 over 100. 28 follows the of, so that goes in the bottom. And is what number? That's the unknown, so we call that the unknown. We do a cross product, and I get 100x equals whatever 13 times 28 is. That ends up being 364. Divide that by 100, and we get 3.64. We'll divide both sides by 100. We should have gotten that out of pre-algebra, I would think. Alright, we talked 73%, so once again 73 over 100. Of what number? We don't know the of, so I'm going to call that an unknown. Is 18. Put that on top. We get 1800 after doing a cross product is equal to 73 times x. I'm going to divide both sides by 73. And I get 1800 divided by 73, which is 24.65. Finally, 15 is So in this case, 15 follows the is, it goes on top. What percent? Unknown percent over 100 of is the 123. Cross product, 123x equals 1500. Divide both sides by 123. And x equals whatever 1500 divided by 123 is, which is approximately 12.19. So that's a real quick introduction into a lot of the number systems, percentages, and fractions. What I'd like you to do is on the form answer these 3 questions, type in your answers, and then make sure you do the lesson summary on the form right below this video. See you tomorrow.